In the previous lecture, we've discussed about antenna parameters. In this lecture, we will apply the formulas that we have learned in the previous lecture to actual problems. Let's take a look at the first problem. For a transmit antenna with R sub R is equal to 72 ohms and R sub E equal to 8 ohms and a directive gain of 20, power input of 100 watts, determine first the antenna efficiency, next the absolute gain and gain in decibels, next the radiated power in watts, decibel, and dBm, and lastly EIRP in watts, decibel, and dBm. First, let's take a look at how to solve for antenna efficiency. So let's write down the formula. Efficiency is equal to R sub R divided by R sub R plus R sub E. Now let's plug in the values. We have 72 over 72 plus 8. And if we calculate for that, we have an efficiency of equal to 90%. Next, let's compute for the antenna gain. Antenna gain is equal to the efficiency times the directive gain. So we have 0.9 times 20. And if we calculate that, we have 18 for the absolute antenna gain. Next, the radiated power in watts, decibels, and dBm. For the radiated power in watts, let's first write the formula. It's efficiency times the input power. So we have 0.9 times 100, which would give us a radiated power of 90 watts. Next, for the decibels, we just have to take the decibel value of 90. So we have 10 log of 90. And then we have the radiated power is equal to 19.54 decibels. And then for the dBm, it's pretty straightforward. So we have the radiated power is equal to 10 log of 90 divided by 0.001. This denominator is what we will add inside the logarithm to get the dBm value. So if we calculate for that, it will give us a radiated power of 49.54 dBm. So still an easy question. And then lastly, we have to find the EIRP in watts, decibels, and dBm. So the formula for EIRP is the input power times the antenna gain. For the input power, it's already given in the question. It's 100 watts. The antenna gain is what we have calculated earlier, which is 18. This is the absolute, not the decibel, so take note of that. So if we calculate this, it would give us an EIRP of 1,800 watts. Next, let's find this 1,800 watts in decibels. So we have P rad is equal to 10 logarithm of 1,800. That would give us P rad is equal to 32.55 decibels. Next, let's find the value in dBm. So it's just equal to 10 log of 1,800 divided by 0.001, which would give us a radiated power of 62.55 dBm. And that's it for this question. This one's pretty easy. Next sample problem. Calculate the captured power 10 kilometers away from a half-wave dipole transmitter with a 10-watt transmitter power for the following receive antennas at 150 megahertz. Now the given here is a Hertzian dipole. Now take note, the problem has a transmitting antenna that is a half-wave dipole and a receiving antenna which is a Hertzian dipole. So we'll take into consideration the gain of these two antennas. So solve for that, let's write down the formula. The captured power is equal to the power density at that point times the effective capture area of the receiving antenna. So for the power density, we have the formula input power times the gain of the transmitting antenna divided by 4 pi r squared, wherein r is the distance from the transmitting antenna. Now let's multiply all of that with the capture area. It's equal to a sub r, which is the receiving antenna gain, times lambda squared. This is the wavelength of the electromagnetic wave being transmitted or being received by the receiving antenna, divided by 4 pi. So let's just plug in the values in our equations. So we have 10, the input power, times 1.5. This is the gain of the Hertzian dipole. You can actually see the gain of common antennas in the previous lecture. So divided by 4 pi times 10 kilometers squared times the gain of the dipole, which is 2.15, times, let's solve for the wavelength, which is equal to the speed of light divided by the frequency. It's 300 mega divided by 150 mega squared. So that would give us the wavelength divided by 4 pi. And then computing for that, we have a captured power of 6.23 nanowatts. For this last problem, determine the percent bandwidth for an antenna with an optimum frequency of operation of 400 MHz and a -3 decibel frequencies of 380 MHz and 420 MHz. So this -3 decibel frequencies are also the half power frequencies. So to get the bandwidth, we'll just have to subtract the two frequencies, so 420 mega minus 380 mega. That would give us an answer, and then that answer divided by the 400 megahertz will give us the percent bandwidth for this particular antenna. So let's write down the equation. We have percent bandwidth is equal to 420 minus 380 divided by 400, and calculating that would give us a percent bandwidth of 10%. So this would be our final answer.